Hey guys, how's everything going? This is JSer, who is not good at algorithms. Today, let's continue our journey on LeetCode to solve the Facebook questions. It should be 1 to 4. Yeah, binary tree maximum path sum. Okay, we're given a non-empty binary tree. Find the maximum path sum. Well, it should be recursion. For this problem, a path is defined as any sequence of the nodes from some starting node to any node in the tree along the parent-child connections. Okay. The path must contain at least one node and does not need to go through the root. Well, this is obviously already gave us a hint that it could be contained in a subtree without passing the root, right? For this kind of problem, I always think this way. Well, of course, it's a recursion. Suppose there's an optimal result, and to find the characteristics between that optimal result with the key elements in our data structure, which is for binary tree, it is the root, right? It is root. So take example 2 as let's see example 2. Suppose that it's optimal result. It might start from 9 and end at 15, but we know the result is like this read, right? But suppose we don't know where it is. Now let's see for -10. What is the possibility of -10? Well, there are, I think, a few possibilities. One, it is not in the optimal result path, right? So it must be the left, or it must be on the right. So that's a typical recursion, right? So if that's the case, we just choose the bigger one of each result from left and right. And or if it is in it, so if it is in it, what's the possibility are? Well, it might be there be something to the left and something to the right, right? This will generate us, or if both of them are not picked, like we only use -10 because we add at least one node. If you only use one node, maybe we could just use this -10 or -10 plus the maximum tree here, or -10 plus the maximum paths here, or both left or right. So there will be 4 possibilities, right? But it's generally a recursion, so let's try to do that. Well, I will create my favorite walk method. It will become a root, receive a root as a parameter, and then what we return. Well, as we analyze here, we want the maximum of left, right? And then if we want to use this, we must start with -10 and then connect to 9, right? And the maximum tree connected with this 9, right? So it must return max and max connected, right? The maximum path connected to 9. It's not past 9. We cannot generate a root like 15, 7 path. Yeah, right. Because one way, right? Or not one way. Just there's only 2 ends. Like these 3, we cannot add 10 if this is a positive 10 here. So we return max connected and do the result. Okay, so let's try left. So it's max left connected equals walk root left. Of course, now root left might be empty, right? So what happens if left is empty? Well, maybe we could return 0, but I tried that, it failed. There's a problem that we are asked to at least return 1 node. So this empty node is not possible. For possible, what we return? Yeah, because we're finding the largest, we will return infinity. To remove the possibility of n null being added into the path. Okay, we do the same to max right. We should use collected. So now let's calculate the max and max connected of current node. For max, as we said, let's first consider the max of connected, right? Const max connected. What possibilities are there? There are 4 possibilities. Math max. First one, itself, right? Next one, left connected, right? Max left connected. Third one, we connect with right connected. Or this fourth one, both of them are used. Oh, no. For connected, we cannot use both of them. Okay, this is wrong. We should use only these 3. This is the max connected. And max, well, max has what kind of possibility? Well, use left, which means max left. Or use right, right? Right. Or use what? Or use the connect, right? If connect, max connect. Or we use both these left and right. So this is, as we said, this is not connect. This 3 is not the connected value we want to return. It should be node value. This should be only used in the max calculation. Well, yeah, now we get a result. We return them. Max connected. And finally, we return walk root. The first one is the result. Huh? Node. Oh, my bad. Maximum cost asked. What? Okay, for net root, which left node null, return okay. This left, this is right. Maximum, max left, max math, max this, okay, we return max connected. Oh, why is left? My god. Okay. Still? Maximum cost stack. What? Yeah. I see what happens, man. Okay. Cool. I think we should work, but oh, there is a wrong answer. So what happens to this solution? Let's try to find it out. Okay, we are checking if a node is null, then its maximum should be negative infinity, and we get left, right? And then we get right. Okay? And then we calculate the maximum connected. It should be node itself, or left, or right, right? Yeah, and then we get the max. Max should be left, yeah, or right. Yay, we forgot the max left. Oh, man. Max left or max right. This should not be connected. Oh, man. Max connected. Yeah. Oh, there's a comma. Let's try to submit again. Cool. We are accepted, and let's try to analyze the time and space complexity. For time, of course, we traverse the node for only once, right? So it's linear time, according based on the count of the node. So space, well, we return an array, but it's just it's constant. It's not constant, but I mean it's only times 2, right? Before we use a variable, we cannot use we now use array. It will be recycled. So the worst case, which means it's a very deep tree, so the worst would be linear time. But we're really slow. what could be the possibilities of improvement? Let's try to see. Actually, this improvement is a very subtle. You see, if this idea is very easy to think about, but about the max thing, you see, for the left, right? For the left and the right, we use them to calculate the max of the current node. But actually, rather than we return it to the parent call like this, we return walk root 0. We might just collect the result as we go, right? Collect the result. But for the root node, we need to get to know the left and the right. So this value must be returned. But this max actually could be collected in a separate variable. I mean, let max equals minus infinity. Okay, now we just return the collected. All right, this connected, of course, infinity, and maximum collected. This is right, and the max. Well, we updated. We updated the max. Okay, it would be max left or max right. There's nothing called this. So actually, it's max connected or all of them connected. Like this or this or this or this, right? The case of fully left, like only from left, will be calculated in the walk recursion call of this root node. So the maximum should be updated. And then we just return max connected. And we walk root and return max. Let's run the code. It should work. But still, there's a wrong answer. What? Let's see where the bug is. Max math. For a node, it should be max connected. Yeah. Or plus left plus right. Yeah. Ah, yeah. Or left or right. So left, right, or itself, or connect left, or connect right, or collect all of them. Still not right. What? Where is the problem? If this is this right? Oh, it's wrong. Why? Okay, the max would be this already checked. So node val left or right or left right or both of them are used. This is the max. My heart hurts. It should be including the max itself. Bingo! We are accepted finally. Wow. No wonder why it is labeled as hard. Okay, pay more attention about how we should do the recursion. We're faster than 80%. Okay, let's analyze the time space complexity. For time, every node is still be traversed for once. So it's linear time and space. Well, for this time, we don't use array, but the time space complexity doesn't change. It's still, in the worst case, it's the call stack, right? We collect the result. This is not tail recursion, so it's a linear space. Cool. That's all for this one. Hope it helps. See you next time. Don't forget to follow subscribe my channel. Okay. See you next time. Bye bye.